Yes, hello everyone. Today I want to teach about titration, and it's a special type of titration called sequential or double indicator titration. When we say a double indicator titration, is a type of titration where two indicators are used in an experiment. So today, with that type of titration, I'm going to use a transcript or a question that will help us to understand how the answers are approached and how we are going to do it. So you are required to determine the percentage by mass of sodium hydroxide and sodium carbonate in a sample Xg were dissolved in. You are provided with the following: sample solution of the mixture of sodium hydroxide and sodium carbonate, standard solution of hydrochloric acid, 0.1 molar of HCl, phenolphthalein and methyl in orange indicators. Yes, no, there are two indicators there, phenolphthalein and methyl orange. So procedure: pipette 25.0 ml of the sample of the solution into a conical flask, add 2 to 3 drops of phenolphthalein indicator, and then titrate with the 0.1 HCl standard solution to the endpoint. Then the content of the conical flask, add 2 to 3 drops of methyl orange indicator, and then continue to titrate with 0.10 HCl aqueous standard to the endpoint. So that is the table. There are two tables because we are going to use two indicators in the experiment. So let us first comprehend the equation by underlining the key terms. So you are required to determine the percentage mass of sodium hydroxide and sodium carbonate. So it means we are going to deal with sodium hydroxide and sodium carbonate. So this Xg, sample Xg, it contains sodium carbonate and sodium hydroxide were dissolved in. So I provided a sample solution of the mixture, that is that mixture that contains these two, sodium hydroxide and sodium carbonate. Standard solution of hydrochloric acid, which has 0.1. Now this is the most important part, 0.1 HCl. So you must consider the concentration of HCl you are giving there. Then there is phenolphthalein indicator and methyl orange indicators. These are the indicators that you are going to use. And in sequential or double indicator titration, you usually start with phenolphthalein indicator. Then after phenolphthalein indicator, you go to the methyl orange indicator. What I mean is this: when you are arranging your apparatus, let me explain the procedure as I do it. So pipette 25 mils of the sample solution. So you're going to pipette 25 mils of the sample solution. What is this sample solution? This is the sample solution that contains sodium hydroxide and sodium carbonate. So it means you are pipetting 25 mils of the sodium hydroxide and sodium carbonate into the conical flask. Then into the conical flask, add 2 to 3 drops of phenolphthalein indicator. So after titrating that 25 and it is in the conical flask, you add the phenolphthalein indicator. You add 3 drops. In my experiment, I added 3 drops. Then titrate with 0. So this one, 0.10 molar HCl, that is going to be in the burette. Let me try to draw it. So when you are pipetting, this one, I'm not a good drawer, but at least you can understand what I mean by that one. So this is the burette, and then this one is the conical flask. So the burette here, it has 0.10 HCl, and the conical flask, it has the sample X, which contains sodium hydroxide and sodium carbonate. I hope you are understanding up to there. Then the content of the conical flask, add 2 to 3 drops of methyl orange indicator, and then continue with the titration with 0.1 HCl. So it's a standard to the endpoint. What they mean by that one is that when you are doing that experiment, you take that sample, then you take the sample which you have pipetted. You have done the titration with the phenolphthalein indicator. Then after finishing with the sample, you add methyl orange to the conical flask that still has the sample that you have gotten your answers on the phenolphthalein. Then you add that one methyl orange inside. Then you continue titrating until the color changes. So I'm going to use table 1 and table 2 to at least elaborate more and make you understand. So this table 1 is for phenolphthalein indicator, and this table 2, it is for methyl orange indicator. So by that one, I mean when our initial reading, mine, I got 0.0. Let us use 0.0 as my measurements which I found them. Then the initial burette reading, what I found on the first one, mine, the final burette reading was 15.1. Then so you must, on answering the table, you must ensure the decimal points are equal. You must ensure the decimal points are always on the same. If there are 2 decimal points, you place all of them into 2 decimal places. If it is 1 decimal place, is 1 decimal place. So I chose to use 1 decimal place. So 15.1, 15.1, then 0.0, 15.1. So here you will do 15.1 minus 0. You get it is 15.1, 15.1, 15.1, 15.1. So this one is the amount of HCl. This one is the amount of HCl used when phenolphthalein was in conical flask. That one. Then this one, the final reading of this one is the initial reading of the table 2, because when you finished this one, you did not discard the constituents in the conical flask. So you had to continue by adding methyl and continuing with titration. So the final reading of this one is the initial reading of table 2. So we'll come and do 15.1, 15.1, 15.1, 15.1. Mine, it won't be that accurate, but at least I'm trying to elaborate myself more, and I'm trying to get the figures that you can easily understand. So the final, it was 20.8, 20.8, 20.8, 20.8. So if you want to get the volume used there, you minus. So you have to do 20.8 minus 15.1, get 5.7, 5.7, 5.7, 5.7, 5.7, 5.7. So after doing that, now we have come to get the bigger picture of what is happening here. We have already analyzed. So I have to explain something that which you will have to understand between these two things. You have to put them in the back of our mind before continuing. Sodium hydroxide, when neutralized, it neutralizes completely because it is a strong acid. So sodium hydroxide, it is neutralized completely. That one, neutralization, and it is AQ plus HCl, which was in the burette. It neutralizes completely to produce sodium chloride, which is AQ plus water. That one is the first reaction that will take place inside there. And sodium carbonate, it dissociates partially, then after some time it dissociates completely. So it undergoes two phases. Phase 1 is halfway reaction and phase 2 is complete reaction. So phase 1, what I mean by phase 1 is sodium carbonate, which is AQ, reacts with sodium carbonate reacts with HCl to produce sodium chloride plus sodium hydrogen carbonate, AQ. So that is the halfway reaction of the first one. And the second reaction is sodium hydrogen carbonate, which is AQ, reacts with that HCl, AQ, to get sodium chloride plus sodium chloride plus water plus CO2, which is a gas. So that is the two reactions that take place there. So let me arrange it this way so that we can understand better. So it is sodium hydroxide reacts completely and faster, yes, produce sodium chloride plus water. And the second one is sodium carbonate, yes, reacts partially, produce sodium hydrogen carbonate plus NaCl, sodium chloride, this experiment. Then this one, yes, then this one sodium carbonate, which is this one here, which is this one, reacts completely to form sodium chloride plus water plus carbon dioxide gas. So it means this one is down here. So when doing our reaction, this one is the major one that is supposed to be considered. So the table we have drawn. So let us explain now these things inside here. So we'll now, as I said, this experiment you're using phenolphthalein here, and this one we are using methyl orange. So let us come back and get what I mean by saying that. Methyl, yes, the final Liberator reading is 20.8. So it means here from here 0, from 0 to here it is 15.1. And then from here 0, this one 15.1, the first experiment, and this one 15.1. What they mean by this 15.1, it also include the sodium hydroxide. So that 15.1 ml is that reaction that has sodium hydroxide and sodium carbonate. Then in the last reaction, where sodium carbonate or sodium hydrogen carbonate was the only one remaining here, then we are going to get 20. So here it is 20.8 ml. So they mean by what we mean here is that 20 minus 15, we get what was used here, between here, and this one is complete reaction. That one is complete reaction, and this one is a halfway reaction. And here there was no sodium hydroxide, but here it is sodium hydroxide and sodium carbonate. So what we mean by here, is that when we minus this one, 20 minus 15, 20.8 minus 15.1, we'll get 5.7. So here it is 5.7 ml. This 5.7 is the halfway reaction of sodium hydrogen carbonate only. So if it is the halfway reaction of this one, it means also here it will be 5.7 ml. So here this 5.7 ml plus 5.7 ml, it is a complete reaction for sodium carbonate. But this one, this 5 from here to here plus, so it means from this halfway reaction plus sodium hydroxide, you'll get 15.1. So if we want to get the amount of sodium hydroxide that was used, we'll take 15.1 ml minus 5.7 ml. So that one will arrive to the amount of sodium hydroxide that was used. So the amount of sodium hydroxide will be 15.1 minus 5.7. So that one is 9.4. So 9.4 ml of sodium hydroxide was used. So by getting to know that one, you can tackle any question that is being asked about that experiment. So let us come and do the questions. I hope you are ready. So write the reaction that take place in the phenolphthalein titration. This one, they mean the phenolphthalein is the first one, that this titration. Write the reactions. So the first one is this one, sodium hydroxide. Sodium hydroxide AQ with HCl, which was in the burette, reacts to produce salt, which is sodium chloride plus water. That is the first experiment, the first reaction, and you must make sure that they are balanced. The second one is the halfway reaction of sodium carbonate, which is NaCl. This one, sodium carbonate plus HCl, which was in the burette. We get sodium hydrogen carbonate plus with sodium chloride. With sodium chloride. This one is a good reaction for acid-base indicators. Then the third one is write the reaction that take place in the methyl titration. Methyl titration, they mean by this one. So methyl titration, they mean by this one and this one. So you'll just take sodium hydrogen carbonate plus, this one is Ag, plus sodium chloride. You can get sodium, sorry, it is sodium hydrogen carbonate plus HCl, sodium hydrogen chloride. You get sodium chloride plus sodium chloride plus H2O, water, plus carbon dioxide. So that one is the first one. And number 3, calculate the volume of HCl required when sodium carbonate is half neutralized. The volume of HCl required when sodium carbonate is half neutralized. So if we come and see where we drew sodium hydrogen carbonate, where it was half neutralized. So half neutralization they meant by 5.7 ml. So our answer here, it will be 5.7 ml. It's that simple. If you have already analyzed here, you just carry your answers to here. So hence or otherwise, deduce the volume of HCl that was completely neutralized sodium carbonate. So reduce the volume of HCl deduce the volume of HCl that completely neutralize sodium carbonate. They want this volume of HCl that completely neutralize this one. So if halfway is 5.7, this one, so it means it is half of that one. So you multiply by 2 to get the complete one. So it will be 5.7 ml times 2. 5.7 ml times 2, you get 11.4 ml that was used. Or you can take 5.7 ml, which is the half, plus 5.7 ml, which will get 11.4 ml. This one is the volume of HCl that was completely neutralized. Okay, deduce the volume of HCl that completely neutralized the sodium hydroxide in the mixture. So we have I've already explained that one, because from here sodium carbonate, from that reaction whereby sodium carbonate reacted to sodium hydrogen carbonate in that halfway, and they are with sodium hydroxide. Here in this experiment, the reaction was 15.1 ml that was used by HCl. That HCl was used, but in this one 5.7 is in sodium carbonate. So sodium carbonate is 5.7. So if you want to get the sodium hydroxide that was used, you'll take 15.1 ml, this one for the whole of the experiment, minus 5.7 ml. So that one you'll get the volume of HCl that completely neutralize sodium hydroxide in this experiment from here to here. So it will be 15.1 minus 5.7. So that one is 9.4 ml. We are getting to understand there. Yes, because this 15.1 ml is from my experiment here, which I used a phenolphthalein indicator in the first experiment. Yes, so calculate the number of moles of HCl that reacted with the whole of sodium carbonate. Calculate the number of moles of HCl, the 1 moles of HCl that reacted with the sodium carbonate. So if we come here, we'll get the amount of HCl. So what is the concentration of HCl? Concentration of HCl. It was from the question. Concentration of HCl is 0.10 molar. So it is 0.10 molar. 0.10 molar will mean 0.10 moles in 0.10 moles in 1000 ml. So by that 0.10 moles in 1000 ml. So calculate the number of moles of HCl that reacted with the whole of sodium carbonate. So the volume here that we used was 5.7 because as we answered, hence deduce the volume of that completely neutralized sodium chloride. So this one is the volume that reacted with all. So we have the volume, which is 11.4, and we have the concentration 11.4 ml, and we have the concentration, which is 0.10 molarity. So we'll say 0.10. If 0.10 is equals to 1000 ml, what about this one that we have here? What about this one? What about 11.4 ml? How many moles are there in 11.4? We cross multiply 11.4 times 0.10 over 100. So this one is moles. So we'll arrive to 11.4 times 0.1 divided by 100. So we'll get 0.0114 moles. 0.0114 moles. So that one is our answer to number 5. Then the last one. Hence, determine the number of moles of sodium carbonate in 25 centimeter cubed mixture. So hence, determine the number of moles of sodium carbonate. So we have number of moles. Yes, now let us calculate the number of moles, because here we are going to use ratios for the ratios, because we have the known to unknown. So the reaction, full reaction in it is sodium carbonate. Now this is a complete reaction, plus HCl produce they react to get sodium chloride plus O2 plus water. So we balance the equation. It is 2. Then here we have 1 hydrogen, here we have 2. So you have to place here 2 hydrogen, chloride 2, 3. Yes, it is a balanced equation. So we have to get the number of moles of HCl first, because that one is the known concentration in 25 centimeter cubed. So we'll say if 0.10 moles is in 1,000 centimeter cubed, which is this one here. We are using this statement. Yes. What about in 25 centimeter cubed? So we cross multiply, get 25 centimeter cubed times 0.10 moles divided by 1,000. So this one here, if we take 25 times 0.10 divided by 1,000, we get 0.000025. Yes, 0.0025 moles of HCl. That one is the moles of HCl, but the question is asking moles of sodium carbonate. So ratio of sodium carbonate, the ratio of HCl is the ratio of sodium carbonate to hydrogen chloride, hydrochloric acid, is 1 here. 1 is ratio 2. 1 is ratio 2. And this one 2 is for HCl is 0.0025 moles. So you say 0.0025 is 2. What about 1? So it will be a half times 0.0025 moles, and you'll get the mole of, so this one you'll get the mole of the sodium carbonate. So it will be 0.00125 moles, and it is that simple. The question is that simple. All you need is to understand this one. This one is the key matter of everything. Thank you.